Hey there, today we are looking at solving DC circuits, and this video will cover some of the more simple questions, straightforward questions, and then the next video in this series will cover more complicated questions. So here we go, let's jump in. Question 1, we have this simple circuit. You can see there's a series circuit because the 3 ohm and the 2 ohm resistors are in series with each other. All the current, we call it I total or IT, it goes through the 3 ohm and it has to go through the 2 ohm. Remember, current cannot just leave the wire. That does not happen. So these two are in series with each other. And we're asking for the current. And what formula do we know? We know Ohm's law, which is V equals to IR. And every time you apply this, you apply it to one component. Well, you can simplify the circuit and then apply it to that component, but you always apply this to only one component, generally speaking. So now it might be tempting to say V equals to IR. Oh, does it mean that V is a 10 and then I is a IIT and then R is, oh, which is R? Which one do I use? No, but that's not the right way to think about it. Apply it to one component. So I like to do this, 10 volts. So if you've seen the previous videos, you see that I will assign a potential like this. And since it is 10 all the way, it's 10 all the way because the wire has no resistance, and 0 all the way. It's 10 and 0. So the thing is, the potential difference across this whole part is 10, but the potential difference across the 3 ohm resistor is actually not 10, and across the 2 ohm resistor is actually not 10, it's some other value. If you see the series circuits video, it's actually split. The 10 volts is actually split between 3 ohm and 2 ohm, and you have to calculate. So this video actually shows you how to calculate it. And so what we can say is that this is, let's call this V1, and let's call this V2. What we can say is that V1 is equal to I total, because that's the current going through the 3 ohm resistor, and V1 is the voltage across the 3 ohm resistor. That's what I meant by applying to one component, multiplied by the resistance of that 3 ohm resistor. That's what we know. And we can also say that V2 is equals to I total, which is the current going through the 2 ohm resistor multiplied by 2. The problem with this is that we have too many unknowns. We don't know all of these. We don't know all of these. I mean, you can say that, oh, okay, maybe we can say, we actually know that V1 plus V2 actually gives me 10. But immediately, you see, that's a lot of equations, a bit complicated. So let me propose a different method. Let's simplify this circuit. If we can simplify this circuit to look like this, where this is my R effective, then we can see very clearly that this, the potential difference across the R effective, is also 10 volts. This will be 10 volts, right? Then we can apply it simply. But how do we do it then? How do we find R effective? We just take 3 plus 2, right? Because both are in series, so we can say R effective equals to 3 plus 2 equals to 5 ohms. And so this is actually 5 ohms. Now we apply V equals to IR. So what is the potential difference across the 5 ohm resistor? It is 10. So V equals to IR, 10 equals to I. I is I total, which we still don't know, so let's just put it I total, times R. R is 5. And there we go. We can solve for I total, which is simply 10 divided by 5, which is 2 amperes. And now let's look at another question that's kind of similar, but the way it's worded is different in the order of things that you solve for. So let's look at part A. It's a 3-part question, A, B, and C, but let's just look at part A first. And part A asks you what is the total current. And so in this case, you may say, hey, can we just use the same way as we did it just now, combine these two and then apply V equals to IR? Well, let's just see what happens when we do that. So if let's say for part A, let me just do it here. You combine both, so you can see that it combines to R effective, right, equals to 5 if you take 2 plus 3, and I total, and V will be the V of the battery. But the problem is they didn't give us the potential difference across the battery. It's also a question mark. So what do? You cannot use this method. But let's look at individual components over here. They've also given us this, which is the potential difference across the 2 ohm resistor, which is 3 volts. Can we apply Ohm's law, V equals to IR, across just this? Do we know the V, the potential difference across this? Yes, it's 3. Do we know the R, which is the resistance? Yes. Do we know, we know both, so we can solve for the current going through. Because the current going through IT coming out is the same current going through this resistor. So we can actually apply instead, so we can say for the 2 ohm resistor, we can just apply V equals to IR, so V, 3, across that resistor equals to I, which is IT, going through that resistor, times R, which is the resistance of that resistor. So you really apply V equals to IR for that component, and immediately you can see that the total current is 3/2. We don't like fractions in physics, so let's just convert that to decimals. There you go. So IT equals to 1.5 amperes. And now let's look at the second part of this question, which is we're asking for the potential difference across the 3 ohm resistor. And so it might be tempting to say, oh, I know V1 plus V2 equals to the total. Oh, but then again, I don't know what this is either. So I can't just add it up. But hey, do I know that now I solve for this? Do I know the current going through the 3 ohm resistor? Yes, it's also 1.5 amperes because the current only has one way to go. 1.5 amperes comes out, 1.5 amperes goes through the 2 ohm resistor, 1.5 amperes also goes through the 3 ohm resistor. So really, what we can say is solving for part B, let me color code it in blue, that let's apply V equals to IR to the 3 ohm resistor, and we can say that V2, which we do not know, equals to the current going through that 3 ohm resistor, which is 1.5, and multiplied by the resistance of that 3 ohm resistor, which is 3, and there you go. We managed to get the potential difference, which is 4.5 volts. V2 is 4.5 volts. And now, let's solve for the last part of this question, which is asking for the total potential difference. Now we can apply straightforwardly the rule, where we know that V1 plus V2, both of them, the potential differences add up to give me VE, and so we can say that 3 plus 4.5, which is simply this, 3 plus 4.5, and they add up to give me 7.5 volts. So the battery gives me a potential difference of 7.5 volts. There you go.